So this is called projectile motion part 1. A projectile is any object in free fall. We actually did projectiles in physics 11, but we didn't give them any sideways push. When I did that catch thing with you earlier, those are all projectiles. We can study two-dimensional projectiles. First, we have a thought puzzle. It says this: I'd like you to imagine that a mass is held at shoulder level and fired horizontally. Let's make it my Nerf dart gun. Let's suppose that I put my Nerf dart gun on my shoulder and it's aimed exactly horizontally. So not down, not up, straight flat. When I pull the trigger, and I'm not going to, which path will the projectile follow? Here are our 4 options. Path A, it's going to drop straight down. Path B, Path C, it's going to go straight for a while and then drop. Path D, it's going to go straight, come to a stop, and then drop straight down. You know, since we have choices, once again, we get to vote. Once again, how high you hold your hand up is how sure you are of the answer. So if we launch a projectile dead horizontal, Nerf dart gun or whatever, what path will the projectile follow? Who says, Mr. Dewick, A is correct? It's going to go just straight down. A. No one. Who says, no, B? 1, 2, I got 3. Reed's jumping in 4. I got a latecomer 5. Oh, now I got 6. Nick jumping 7. 8. Got a few bandwagons. Okay. Oh, 9. Yeah, 9? 9. Who says C? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Who says D? Convince me. Yeah. What are you going with?
So B.
Yeah.
I would imagine that it would have to be D because it can't be dropping straight down because you're actually putting...
Okay, A is nonsense. Gotcha.
And D is...
Nonsense?
Yeah.
By the way, A and D, I grew up with cartoons. We used to call that Roadrunner physics, especially D. If you watch the old Coyote and Roadrunner cartoons, the coyote would run off the cliff, not realize that he was in midair, come to a complete stop, and then fall. And that's nonsense. Okay, so B or C, which one?
B.
Yeah, why?
Because in the case of C, well, gravity is still affecting it. It can't just go straight.
Gravity acts right away. And here's the problem. You've been lied to by movies. How many of you, at least once in a movie, have seen the classic camera shot? There's a sniper scene, and they show the camera looking through the sniper sights at the target. How many of you have seen that at least once in a movie where you and the little crosshatch lines up right on the target? Yes? Stupid. If that's all it took to be a sniper, any idiot could be a sniper. In real life, snipers are aiming way above the target, and they have to calculate how far the bullet's going to drop due to gravity, because as soon as the projectile leaves, gravity is going to act right away. It's very difficult to be a sniper. You have to figure out how far away the target is. You then have to figure out how long it'll take the bullet to get there. In that time, how far will the bullet drop? Oh, it's even worse if there's actually a crosswind. You have to take that into account. Oh, and by the way, the physics that I'm teaching you, Keegan, is wrong. We're pretending the Earth is flat. It's not. You actually have to take into account the curvature of the Earth. That's why they have to train. If all it took was, lining up that little crosshair, any idiot could do that. The movies have lied to you. They show you bullets traveling straight. Bullets do not travel straight. As soon as bullets leave the gun, they're in free fall and they are dropping down. So it says, defend your answer. You're right, but I don't want to write that much. Oh, you know what? How about this? Gravity acts instantly. There's not some kind of a delay. Those of you that pick C, it's not like gravity. Oh, I wasn't paying attention. Hi, bullet. Now we'll start pulling down on you. Or it's not like somehow the bullet has magical flying properties and then only then starts to fall.
If the velocity, like changes the velocity is high, wouldn't it be close to C?
It arcs right away. It's falling right away. Here's what would happen. If you zoomed out and you let the bullet travel for a longer time, you would see the same as B. It would be a shallower arc, but there is no straight line, and then, how gravity's paying attention now, and now it falls. Oh, this gives us another thought puzzle. We get to vote again. Let's suppose we repeat the experiment, but we have two identical masses. So here's my Nerf dart gun. At the split second I pull the trigger, I'm going to drop a second dart. Which one hits the ground first? Here's our options. Two identical objects are held at the same height above the ground. Object 1 is released and falls straight down. At the same time, Object 2 is projected to the right, let's say from a Nerf dart gun, and it falls to the ground. Which one hits the ground first? Option A, Object 1 because it has a more direct path. Option B, Object 2 because it's moving faster. Or Option C, they both hit the ground at the same time. Ooh. Once again, we're going to vote. Once again, how high you hold your hand up is how sure you are of the answer. Once again, I'll give a glare to somebody who blurted out an answer trying to sway other people's votes. This is an election. It's a secret ballot. Until we vote, we don't blurt out answers. Okay. Who says, Mr. Dewick? A. Mr. Dewick, A. It's traveling less distance, so it'll get to the ground faster. A. A. Who says, no, B, because Object 2 is moving faster. Of course, the speeding bullet will hit the ground faster than a falling bullet. Oh. They both hit at the same time. You're all correct? Convince me. Yeah. What forces are acting on it horizontally? Nothing. What's the only force acting on it vertically? And in terms of the vertical direction, both of them are being dropped. I know one's being shot sideways, but that's a horizontal velocity. Both of them have an initial vertical velocity of 0. They're both accelerating at negative 9.8. They're both going to hit the ground at the same time. Yep. In fact, I have a lovely video of this. This is a pretty expensive apparatus, so I haven't bothered buying it. I think I priced it out at $400. This is from MIT. Thankfully, they can afford it. So we're going to set up a very, very straight up and down pole. We're going to use a level to make sure... Oh, jeez. We're going to use a level to make sure everything is upright. And here is our cannon. Now, this cannon is a little spring-powered cannon. Okay? Not gunpowder, but it uses a spring. Forgot I had sound turned off. So the way we're going to arm the cannon is in two ways. On one end, there's going to be a billiard ball with a peg running through it. When we fire the cannon, that peg is going to jerk sideways, letting the billiard ball fall straight down, like this. On the other end, we're going to put a billiard ball on a little platform, and when we fire the cannon, the billiard ball is going to get pushed sideways, launched sideways, like my Nerf dart gun. What was your prediction? Which one's going to hit the ground first? What did you say? Yeah. Even with air resistance. Yeah. Listen. Okay. Here's what this really means. When we're talking about a two-dimensional projectile, what's happening horizontally does not affect what's happening vertically. They are completely independent of each other. In this demonstration, both masses have identical vertical motions. They have the same vertical displacement, same height. They have the same vertical acceleration, negative 9.8. They have the same initial vertical velocity. One's being dropped, so VI is 0. The other one's being fired horizontally, which means for a split second, since it hasn't started falling, vertically, VI is 0. One key idea. What's the horizontal acceleration of any projectile? 0. I don't want to write that. Too much writing. What's a good abbrev for acceleration? What's a good abbrev for horizontal?
X.
In fact, we're going to call this, not to be insulting, a physics no-brainer because we've memorized it. We know that horizontally for a projectile, I can write that down without thinking about it. Oh, you know what else I can write down? What's the vertical acceleration exactly as a number? You memorized this last year. Negative 9.8. I'm going to call these my two physics no-brainers. If I'm solving something horizontally, I can write that down without thinking about it. If I'm looking at a projectile vertically, I can write down AY equals negative 9.8 without thinking about it. If you were to look at a stop-action strobe video of a projectile being launched horizontally from a cliff, you would notice every time the camera flashed, the horizontal distance would be the same. Every time the camera flashed, it would have traveled the same horizontal distance, but it would have fallen a further distance each time. Why? Vertically it's accelerating. Horizontally, what's AX equal to as a number exactly? So it's going to be at a constant speed, just putzing along. Vx is constant. Vy changes. How come? Well, what's Ax as a number exactly? What's Ax as a number exactly? What's Ay as a number exactly? If there's no acceleration, Keegan, or A is 0, of course your velocity is going to be constant. But if there is an acceleration, of course your velocity is going to be changing. That's what's going on whenever you throw something. One of the really neat things, by the way, we're going to get into some pretty complicated math, and it's going to take us a long time to get the quote-unquote right answer. But all of you figure out how to do this in your head when you're about 6 or 7 years old. Because for all of you, if I throw something, you can look at only the first split second, figure out where it's going to come down. You've done the quadratic formula in your head and estimated the time, and you can go and stand there and catch it. Baseball players and football players do it all the time. Most people can position themselves underneath a projectile to catch it. So it's really impressive. We just do it intuitively. Doing it properly is much tougher. Put your pencils down, look up. So, what's the horizontal velocity? Constant. The vertical velocity is changing. Here's another nice apparatus. This one runs about $1,000. What we have is a spring-loaded cannon right there. We're going to put a golf ball. And when we give this cart a push, right when it gets to here, the golf ball is going to get shot in the air. If there's nothing happening horizontally, the golf ball should stay right above the cart, and when it comes down, it should land back in the funnel again. If that's the case, that means horizontally there's no acceleration. Let's see. This is also a really finicky apparatus. I saw behind the scenes setup, and it takes a few hours. Why does it take so long? I'll explain to you. So we've armed the spring cannon in there. We give it a push. The golf ball should stay above the cart. Yes? The reason this is so finicky, it's really hard to get it to shoot exactly up. at an angle of 90 degrees. In fact, you're going to see the golf ball is going to be off a tiny bit. It's probably firing at 89 degrees or 91 degrees. It's really tough to get it to go bang on. So if you watch when it hits the funnel, a student called me on this one a couple of years ago. Hey, Mr. Dewick, it was a tiny bit forward. Yeah, they couldn't quite get it to shoot exactly straight up. It's really tough. But have I convinced you? There's another way you can try this yourself. If you're just walking and you throw a ball in the air, it comes back down to your hand because you and the ball moved at the same speed. Isn't it behind you or in front of you? This is why if you're sitting in a car that's moving at a constant velocity, if you throw something up in the air, it will come back down to you as well because both you and the ball are moving with the same horizontal constant velocity and there's no force acting on you. Horizontally, the acceleration is 0. Vertically, the acceleration is negative 9.8. Example 4 says this. Consider this. Did I hit pause? I didn't, did I? No. Consider the stop action picture of the projectile below. So here's kind of a strobe photo. Starting out, we launched it at an angle. Did I say angle? I broke it into components right away. I said there's Vx and there's Vy. Okay? One of those won't ever change. Which one?
Yes.
Vx is going to stay the same length. In other words, I can draw Vx as a vector right there. I can draw Vx as a vector right there. I can draw Vx as a vector right there. Do me a favor. On this one, put the Vx above. You'll see why in a second. And I can draw Vx as a vector right there. Put it above. Which one is going to change? Nick, you're right. Vy. Because that's where the acceleration is. On the way up, will the ball speed up or slow down? Be obvious. When you throw something in the air, on the way up, does it speed up, going faster and faster away from you? Or does it slow down? Slow down. So right here, Vy would be smaller. Right? Slowing down. In fact, if you want me to find the tip to tail, the actual velocity would be slower. I rarely care about the slanty velocity that I drew in red. I'm just drawing it in there to let you know we could have these tip to tail, but I'll almost never ask you to find it once in a while. What about at the top? The only vector left is Vx. Vy is 0. So at the top, the overall velocity, the slanty one, happens to be Vx, because that's all that's left. What about at the bottom? Well, when you get back to the same height as over here, you're going down with the same magnitude. So it would look, Vy would be the same size as Vy on the way up, but pointing down. That's why I told you put Vx above. That way when we draw the resultant, it's not inside the triangle and making things look yucky. And right when we hit the ground, what goes up must come. That works for slanty at an angle, did I say angle components as well. If you launch at 72 degrees above the horizontal, you're going to hit the ground at 72 degrees below the horizontal, and your components will have the same magnitude as before. It's just Vy, instead of pointing up, will point which way? Vy, instead of pointing up, will point which way? But Vx will stay the same. So see how long this Vy is? I'm going to eyeball it and draw it this long over here. And my, right when I hit the ground resultant would be just as big as when we launched, but on the way down instead of on the way up. Example 5 says, indicate velocity components on the stop action picture and then fill in the key facts about two-dimensional projectile motion. This is the toughest question by far. The easiest is horizontally from a cliff, trust me. The next easiest is from the ground at an angle. Did I say angle? Did I say angle? Did I say angle? Okay. The toughest is from a cliff at an angle. It's components and yuckiness, but we're going to handle it. Right when we launch, it kind of looks like that. If I broke it up into components, I would say there's Vx, And there's Vy. Now, Vx is never going to change, so at the top, I'll draw Vx the same length as I drew down below. And right here, I'll draw Vx the same length as I drew when it started. And right where we're hitting the ground, Vx doesn't change. Nick, which one does change? Yeah. Okay. What is Vy at the top for a split second? Okay, so I'm going to make a little note here. Vy equals 0. When we get even with the launch again, Vy would be the same magnitude as when we started, but negative. So you could kind of say this. Vy equals negative Vy initial. Same magnitude, but pointing down. What about when we hit the ground? Do you think the vertical component is going to be bigger or smaller than when we launch? Yeah. Yeah, so when we hit the ground, Vy would look something like that. Oh, by the way, Quinn, what would it not be when we hit the ground ever? I yelled at you yesterday about it. Help me out.
0.
It's not 0. Good, I'm glad you couldn't remember. Maybe I just reinforced the wrong answer. Maybe I shouldn't have said anything at all.
2 things were yelled at.
So, horizontal speed is constant. Not changing. Why? Because AX equals exactly what as a number? By the way, if it seems like I'm flogging this, can you guess what by far the most common mistake students make? They want to put an acceleration in for horizontal. They want to put the 9.8 in because it creeps them out. Well, there's no acceleration. Yes, there is. It's a number. 0 is a number. It's a nice number. It's a great number to do math with. Vertical speed is, what word's going to go here? Also starts with a C. Changing. Because AY is, everybody? Yeah. This is the one I told you last year you'll end up memorizing out of laziness. And the horizontal and vertical components are independent of each other. They don't affect each other. By far the biggest mistake, Wolf, kids want to put a horizontal value into a vertical equation, or they're going to put a vertical value into a horizontal equation, and you'll see me snap. But I haven't convinced you that they're independent. I came across this YouTube clip, and I thought, oh, that's not bad at all. Look up. Here's a great illustration that your horizontal and your vertical components are independent of each other. Okay? Some of you weren't paying attention. I'll show it again. Right? There's a vertical component. Negative 9.8 is the acceleration, except right when he hits the trampoline. While he's in free fall, negative 9.8. And horizontally, not a problem. We're going to finish with this. Are we? I love example 7. I love example 7. I love example 7. Example 7, will you marry me? Why would I say that? I absolutely positively what?
Okay.
What does that mean when I'm that emphatic? Okay. I'm going to be really blatant with you. Your test is going to have 4 written questions. How many?
4.
One's going to be boat crossing river or airplane in a crosswind, which is really the same physics. There's going to be horizontally from a cliff, like this. Psst, I'm telling you about the test. There's going to be from the ground at an angle. Did I say angle? And then there's going to be from a cliff at an angle, which not going to get to in this lesson. And in fact, what I'm going to do right now is I'm going to pause here. I'm not even going to get to example 7. Your homework is nothing from here. Your homework is, if you're looking for something to work on from the review in kinematics, you might try some of those. I'm a little worried because I could tell you were getting tired. I really shortened the homework in yesterday's lesson because in theory it was review, but I sensed some of you from first semester were going, I don't remember any of this. So practice.